You know, when you see these sprawling digital worlds, these incredible animations, and you just think, wow, how is that even possible? How much code does it take to build an entire universe from nothing?
Well, get ready for this. What if I told you that sometimes it doesn't take thousands and thousands of lines of code? What if it just takes a handful of characters? I'm serious. We're talking about intricate, moving, beautifully lit scenes generated by a piece of code that is literally smaller than a short social media post. It totally feels like magic, but it's not. It's actually the result of some incredible creativity and some just shockingly elegant math. So let's dive in and explore how these artists use physics and math to basically paint with code, all while sticking to this insane self-imposed limit. First up, let's see how they recreate light itself. Okay, let's start with atmosphere. Think about something like realistic, glowing fog. In a normal video game or animation, that could take thousands of lines of code. But in one of these tiny demos, the artist found a way to do it that's, well, it's just mind-blowingly simple. The secret sauce here is a technique called ray marching. Now, imagine that for every single pixel on your screen, you shoot out a tiny probe, a ray. That ray marches forward into the digital space. At every step, it asks a simple question. Am I about to hit anything? If the coast is clear, it takes a big leap. But if it's getting close to something, it takes a tiny little step. It's a super clever way to feel out a 3D scene. Okay, so that works great for solid objects. But what about fog? Fog isn't a solid object, it's everywhere. How in the world do you calculate light bouncing around inside it without writing a novel's worth of code? Well, the solution, it turns out, is this beautiful little mathematical shortcut that was hiding in plain sight the whole time. And you know, when the artist first saw this technique, they had the exact same question you're probably having right now. Okay, is this just a neat-looking hack, or is there some actual real-world physics behind this? Turns out, it's the real deal. All right, so how do we get from complicated physics to a tiny piece of code? It all starts with this beast of a formula. Now, don't worry, you don't need to understand the math. Just know that this is the physically correct way to calculate light density. When you solve that big integral, things get a little cleaner. You get that fraction. But here comes the magic. The big aha moment is remembering how ray marching works. The size of your next step forward is always the distance to the nearest object. So when you plug that insight back into the equation, the terms on the top and bottom just, poof, they cancel each other out, and you're left with this impossibly simple, beautiful result, just 1 divided by d. And that's the whole trick right there. That tiny formula, 1 over d, gives you a physically plausible model for glowing fog. All that intense physics, all that complexity, just boiled down to 3 characters. It's so elegant, so efficient, and it saves an absolutely massive amount of space. Okay, so that's how you light a scene. But what about building the world in the first place? How do you create an entire natural-looking landscape that feels like it goes on forever? Well, you've probably guessed it by now. The secret is another simple, elegant mathematical twist. I mean, just look at the difference here. It's night and day. On the left, you have standard noise. It's a pattern, sure, but it's repetitive, it's uniform, it's kind of boring. But on the right, that looks like a real place. It looks like mountains and islands and a coastline. The technique that makes this incredible change possible is called domain warping. The best way to think about it is like this. Imagine your computer screen is a perfectly flat, stretched out sheet of rubber. Domain warping is like taking that sheet and pinching it and stretching it and twisting it before you even start to paint. By distorting the space itself, you introduce all these natural, flowing, chaotic patterns. So what kind of crazy, complex code does it take to create this effect? Are you ready for it? It's this. That single line. A simple little function that just uses a sine wave to distort the coordinates before they're rendered. This one tiny piece of math is the engine that generates that entire, beautiful, infinitely scrolling world. It is absolutely wild. So we've seen the how. These amazing little tricks and elegant math. But that brings us to the bigger and maybe more important question, why? Why on earth would anyone choose to impose this incredibly strict 512 character limit on themselves in the first place? Well, that number, 512, isn't totally random. It's actually the character limit for a post on the artist's social media platform. So what started as just a practical limit kind of blossomed into this powerful creative philosophy. And the reasons for embracing it are actually pretty profound. Think about it.
A hard limit forces you to focus. You have to master one technique perfectly. It gives you a clear finish line, so you actually complete your projects instead of letting them become these huge unfinished monsters. It also turns coding into a kind of performance art, and it brings back the simple joy of being a craftsperson, just perfecting one tiny, beautiful object.
This quote really just says it all, doesn't it? In a world where we have infinite tools and infinite possibilities, sometimes the thing that unlocks the most creativity is a radical limitation. It forces you to be elegant, efficient, and truly ingenious. So it leaves you with this final thought. It doesn't matter if you're a coder, a writer, a musician, or anything else. What incredible, focused, elegant masterpiece could you create if you gave yourself a truly radical constraint? What would you build with your 512 characters?